Hey everyone, welcome back to our channel. This is a comprehensive tutorial on deploying Docker images to AWS ECS, or better known as Elastic Container Service, using the ECR or Elastic Container Registry. In this specific tutorial, we'll guide you through each step from setting up your environment to successfully deploying your application on ECS using Fargate. First, let's talk about what ECR, ECS, and Fargate are. ECR, or Elastic Container Registry, is a fully managed Docker container registry on AWS. Amazon ECS, or Elastic Container Service, is a fully managed container orchestration service. And a Fargate is a serverless compute engine used for containers and it works closely together with the ECS. It allows you to run containers without having to manage the underlying infrastructure, meaning you can actually focus on running your applications without having to worry about servers, scaling, or availability. Fargate provides a simple and cost-effective way to run containers in the cloud. For this demo, we will use Fargate, which handles all the infrastructure management for us. This means no provisioning, configuring, or scaling clusters of virtual machines, making this really easy for us to deploy and manage our containerized applications. All right, so let's get started with creation of our demo app. So we'll go to Visual Studio Code, and here we've created a demo folder called Heading Clouds Demo ECS. And also in this folder, we have a couple of files. So we've got a very basic Express web application that we've defined, which will basically just give us back welcome to Head in the Clouds. This is our demo on deploying Docker images. We will also be using the port 3000 for this. And also we've got the package.json file in here, just giving some basic information about our application, version, some of the scripts for starting the app, and also a little bit more information about the author and also dependencies for basic installation of this application in the most effective way. We will also as we'll be using Express for this, ensure that all the packages are installed. So let's do npm install save Express. And we'll also run npm install save NodeMon. And we've got all the packages installed at the moment, as we can see here. So also on the left-hand side, we've got a list of Node modules. We've got our application here. We've also got a lock.json file and the package.json as well. So once that is in place, we'll extend the terminal window a little bit, and we'll do npm init. This is basically going to initialize the node project by running this command. So we'll just press enter, use the default configuration for this, and once we get to the very end, we'll just type yes, and that's perfect. And now we'll do npm start to actually test this application. So we'll just open an internet browser and go to localhost 3000. As you can see, welcome to Head in the Clouds. That's the message we also specified in our app.json. So let's exit that, and we will now touch Dockerfile, and let's extend that file a little bit. In here, we will create a Docker file with the following contents, just because we're building this on the Mac machine with the Apple M1 chip. We also want to highlight there was initial error that we experienced as well whilst we were building this Docker image. So the problem was actually related to the M1 chip due to the incompatibility issues. And of course, for those ones with the same problem, we just managed to fix this by adding the following line at the top. So from platform, and we'll do Linux MD64 node LTS Alpine. So this is the platform that we're going to be using for the base image. Then we're going to set our work directory to app. We will also copy our package.json and package lock.json. We'll install the dependencies as such, and we'll also copy the rest of the application code to the working directory. We'll also expose the port 3000 where the application is going to be running, and we'll also specify the command used to start the application. So that will be npm and then start in here. And let's test this by building the actual Docker image. So we'll do docker build -t, let's call it head in the clouds, NodeJS app, and we'll specify dot to look for the local Docker file. We'll run through the build, and once that's completed, we will check our Docker images. Perfect, so let's do Docker images, and in here we can see the newly created one. Let's also test that this is actually working, so we'll do docker run 3000, which is our port number, and we'll do NodeJS app, which is the app Docker image that we just created now. It's starting the container, and if we go back to our internet browser and do localhost again on 3000, we'll be able to see and retrieve the message successfully back, which is absolutely great. And once we have this in place, we will proceed next with some prerequisites that we'll need before proceeding further. So some of the prerequisites we would like to highlight at this point are the actual AWS account. So if you haven't signed up for it just yet, please do make sure to do so. You can also benefit from the AWS free tier on the actual sign up for the accounts. Also, if you go to AWS console, once you create the accounts, and under the IAM service, so Identity and Access Management service, you should also make sure that you have the right policies and permissions in place. We've added here the Amazon ECS full access for this particular user that we've created for this exercise. So you can pretty much call it anything you like. In this case, it can be a demo user or head in the clouds user. And also, if you go to the inside the users under security creds, in here you'll be able to see the access keys if you haven't retrieved them. On the initial creation, you can create a new set of access keys in here, which you can retrieve to also be able to set up your configuration in terminal through interaction, let's say for the command prompt or CLI. So please do also make sure that you do have AWS CLI installed and configured on your local machine. We have already done previously the AWS configure, so we've used the access key ID and the secret access key for that. Also make sure that you are specifying the region you're going to be working in, and also the default output. In this case for us, we've decided to use JSON. All right, so we're back in terminal. Now we'll run a command using the AWS CLI to create an ECR private repository where we'll be storing our Docker image. So to do that, you can do AWS ECR create repository, and then we'll give a repository name. We'll call it Head in the Clouds NodeJS app. We'll also specify a region what we're going to be working in, which is EU Central 1. Super, that's been created now. We are actually going to double check this on the actual AWS console. So if we refresh our page in here, if we can list all the repositories, and here we'll be able to see a new private repository that we just created now, Head in the Clouds Node.js app. And in here we're actually going to be creating and storing our Docker image as well. So we'll go back to our terminal. So before we do that, we're just going to click on this button here called View Push Commands, which is really useful. You can choose here between different operating systems that will serve you as a guidance to ensure that you are correctly authenticated, and that you can also do the Docker builds, tag of the actual image and push to our newly created repository. So let's go back to the terminal. We'll run this command to retrieve an authentication token and make sure that we are authenticating our Docker client to the registry. As you can see here, login has been successfully completed. After that, if we just do Docker images, and here we're going to be able to see our previously created image, so we can skip this step here as the image already exists, and we'll jump into step 3 where we're going to tag our image. So if we do Docker images once again, and here you'll see this image here that will be pushing to our ECR. And if we copy the last command and do the actual push, it will do all the preparation and finally go through the last steps and push the Docker image to our repository. So if I refresh that, leave a couple of more moments to finalize this. And there it is. So if I refresh that once again, we can see our image here with latest tag and also some more information about the actual size, image URI, and etc. Once that is completed, do make sure that the actual Docker image exists in your private repository that we've just created now before we proceed further, as in our next steps we'll be creating the ECS cluster and of course task definition with the service to be able to deploy our containers to. Perfect. Now we will go to ECS service, so Elastic Container Service, and under here we'll click on Create Cluster. We will give it a name, let's say Head in the Clouds Demo ECS. We'll scroll through and we'll make sure that AWS Fargate serverless is ticked under the infrastructure. We don't have to worry about these for the time being. We can just leave them as they are per default. Go ahead and create the actual cluster. It will probably take a few moments to complete that. If you're curious, you can also go to this link here, which will take you directly to CloudFormation, and you can also see all the processes that are happening in the background whilst you're executing the creation of our new cluster. So we can see that is still being finalized, so it's being in progress in the background. Whilst it's doing that, we can proceed further by defining a task definition. So in AWS ECS, a task definition is basically a blueprint that specifies how Docker containers should be configured and run, specifying the Docker images, CPU, memory requirements, networking settings such as port mappings, environment variables, data volumes, and so on. So without further ado, let's just go and create a new task definition so you can actually see how that looks in the real demo. So let's just call it demo task. And if we scroll down, we'll just leave it as AWS Fargate. We're also happy to use the same config for CPU and memory. You've also got here a dedicated role. So for ECS task execution role, we'll keep that as it is. And under the container, we are going to call it, let's say, NodeJS app. And under the image URI, we'll actually go back to our repository, and in here do make sure that you actually go to the repository itself and then copy the URL, because we do want to make sure that the full path is included with the tag itself as well. So as you can see here, we've got also the actual name and the corresponding image tag as well. We're going to scroll through, and here, as we specified in our app, we're actually using port 3000. So, and also in our Docker file, we'll be able to see that. So in here, we'll specify container port 3000. We can call this, let's use previously created ones, and we'll leave all of this pretty much as default. If you want to, you can leave also log collection if you'd like to see some logs that are being gathered through CloudWatch, and also we can leave storage as it is for now. Let's go ahead and create our task definition, and once that is being created, so let's just go back to our cluster, heading clouds. We can also see under here, let's see, oh sorry, task definitions. Actually, yeah, there it is. It's being actually active, which is great. We're also using the latest version or revision number 4. And if we go back to the cluster, under service, we'll create a new service. We'll use the capacity provider strategy as it is. We'll leave that by default. And on the service, we will specify the actual family, which will be what we've just seen now, the actual task definition, using the latest revision number 4. We'll also give it a name, let's say head in the clouds, NodeJS service. We'll keep desired task to number 1 at the moment. And if we scroll down under networking, this is an important part. We'll keep the default VPC with subnets as described above, but in here we'll do Node.js new security group, allow 3000, and in here we'll also make sure that we are doing custom TCP on port 3000 and from anywhere. We'll also make sure that the public IP has been turned on, and that is pretty much it for the service itself. So with the task definition being already in place, we can conclude that and think about it as our container setup plan. And when you want to actually run containers based on this predefined plan, then you can create something that's called a service, as we've seen just now. And the service will manage these tasks over the long period of time, ensuring further on some automatic scaling, load balancing, health monitoring, and etc. So let's continue with creation of the service. If we go back to our clusters, and here we'll refresh our window. It'll probably take some time to go through the actual creation. So let's just give it a few moments to complete that. And if you go to task, you can also see this task being provisioned. So the latest status is currently pending. And if we wait a little bit more, we should be able to see our service being active and running, as you can see over here. We can also switch to tasks tab and click on the task itself. Under here, we'll copy the public IP address, and we'll make sure that we're specifying port 3000. And there it is. We can see that our application has been successfully deployed to ECS using previously created Docker image has been pushed to AWS ECR. And yeah, this is concluding our demo being successfully completed. So we managed to get to the final and to basically run through all the previous tasks to also show this to you how it's done in the real world. And that is it. You have successfully deployed a Docker image to AWS Fargate on ECS using the ECR. In our next video, we'll be covering deployment of an application to Elastic Beanstalk. So please do stay with us. If you do have any additional questions or need further assistance with any of these exercises, feel free to leave your comments below. So don't forget to like, share, and subscribe for more tutorials. Thanks for watching, and until next time, bye bye.